Welcome.
Okay. Well, great news, Dr. Howard. I'm going to give your introduction now that we have a whole lot of folks waiting to hear your talk. So again, this is Laurel and Ann here. So glad you're with us today. John Howard is the director of NIOSH and the administrator of the World Trade Center Health Program in the U.S. Department of Health and Human Services. Dr. Howard was first appointed NIOSH director in 2002 during the George W. Bush administration and served in that position until 2008. In 2009, Dr. Howard worked as a consultant with the U.S. Afghanistan Health Initiative, and in September of 2009, Dr. Howard was again appointed NIOSH director. He was reappointed for a third 6-year term in 2015 and a fourth term in 2021. Prior to his appointments as NIOSH director and the World Trade Center Health Program administrator, he served as chief of the Division of Occupational Safety and Health in the state of California's Labor and Workforce Development Agency from 1991 through 2002. He earned a Doctor of Medicine from Loyola University of Chicago, a Master of Public Health from Harvard University School of Public Health, Doctor of Law from UCLA, and a Master of Law in Administrative Law and Economic Regulation, and a Master of Business Administration and Healthcare Management, both degrees from George Washington University in Washington, D.C. Dr. Howard is also board certified in internal medicine and occupational medicine. He is admitted to the practice of medicine and law in the state of California and in the District of Columbia. He's a member of U.S. Supreme Court Bar. He has written numerous articles on occupational health policy and law. And as you could tell, he is a true leader at NIOSH and really for occupational safety and health worldwide. So we're so glad he's here to talk with us today. Welcome, Dr. Howard.
Oh, thanks a lot. Yeah, don't clap yet. I haven't done anything. So can I share my slides? Will that break the system? I hope not. Can you guys see the slides?
Yes.
Ah, wonderful. Okay, thanks a lot. Happy Friday the 13th, very lucky day. And so I'm going to talk about the future work and from a advanced technology standpoint, which has actually a lot of sort of reverberations to worker well-being. And I think all of you are experts in that area, and I hope that you can listen to sort of my survey course here on advanced technologies and then be able to understand how they may affect the workforce in the future. So I started out asking this question, given the future work of advanced technologies, how is it going to really affect me as a worker? And the answer is, in case you guys fall asleep during the lecture, that I want to give you the answer right away. It depends. And it depends on an analysis that is at the root, an economic analysis, actually. So if you have an AI-enabled robotic device, let's say sort of the cutting edge advanced technology, and it can assist you in performing your job more productively, then the device is a complement to you. It's the complements that we saw in the 90s with computers helping us do our jobs, and now they're an essential complement to us. We could not be productive without them. But if this kind of an advanced technology can perform all of the job tasks that you currently perform, then essentially the device is a substitute for you, and we don't need you anymore. And that raises the issue of technological job displacement. So when we look at these technologies that we hear about all the time, AI and robotics and sensors, big data, cloud computing, cybersecurity, all of these terms are out there. And it's really a struggle to figure out how they relate to each other. And I've drawn these arrows here because they all kind of relate to each other, which is really not helpful in getting a clear understanding of where we're at in terms of these technologies and work. So I've come up with my own model for advanced technology understanding. And it really has three components to it. I'm sort of saying I can put everything and all of these technologies into these three components. So the first is, and when you're thinking about these technologies, in the back of your mind, you must keep in mind the fact that they are reproducing us as workers, as human workers. So, first, like us, there's the sensing component. And in this case, for advanced technologies, it's data inputs. Thinking is the second component, which is done through a very large number of advanced AI methodologies. And then there's acting. You could have a steel collar robot, embodied robot, a humanoid robot pictured here in this slide that takes physical actions. Or you could have your friends, Siri and Alexa and all your personal friends there that are disembodied, and they're white collar robotic devices, if you will. And their production is not taking physical actions, but they recognize your voice and they have their own voice and they can have their own digital output. So keep in mind sensing, thinking, and acting. And let's go through those in a little deeper fashion. So we have five senses, right? A worker has five senses. Yes, taste is one of them. If you're an enologist and you do wine tasting for a living, hearing, obviously, sight, smell. Yes, there are people that use their noses all the time for food production and others. And then there's touch. All of these are our senses. And we see that there's this tremendous industry, multi-billion-dollar industry now that is evolving in our own personal lives with regard to wearable sensor technology. Some of you probably have a Apple Watch on right now that's telling you whether you're in sinus rhythm or whether you're having a little burst of AFib. All of these devices that we see here are becoming more advanced. The sensor technology is remarkable. Not only is there a sensor, but also it has data processing capabilities, and it can be wirelessly connected to your doctor who could be looking at your cardiology output, enabling continuous monitoring and analysis of data 24/7, totally different. So what about the workplace? Well, we see the same thing. There's been placeable sensors around forever. Industrial hygienists excel in this profession, looking at ambient work environments. But you could also say, well, let's put some of these new sensors around a workplace and let's create a data warehouse of data interpretation that I can look at 24/7. Not just the old style sort of attaching a midget impinger on somebody's collar or their equipment they're using. But now we see attachable sensors attached to the workers' clothing, embedded in their clothing, head, arms, wrists, feet, sometimes even computer display eyeglasses, contact lenses, devices and sensors placed in the auditory canal. We see a new world of functional fabrics, electronic textiles, sensors woven into textiles as clothing. We've also seen electronic epidermal wearables, skin-like films or tattoos that can be applied to a worker's skin. And then we see implantable sensors. The NASA, the Goddard Space Flight Center, pictured here, invented one for astronaut travel. We see those implantable sensors for temperature, for instance, swallowed as capsules in gold mines in South Africa. But we can see microneedles or microchips, other types of wearable sensors. And here's a picture actually from Inman Mills in South Carolina, which is looking at sensors being embedded in clothing, in fabrics for use, functional materials now, just not plain sort of static textiles. We now want textiles to be functional. And here's a journal, which I'm sure you all take, Advanced Functional Materials, and a picture of a tattoo, an epidermal sensor to attach to a worker, somewhat like the old style midget impinger, but definitely different. So let's talk about the phase of thinking. We all know what the term AI is. It means absolutely nothing. It's a big umbrella term that we use all the time for shorthand, but it doesn't really help us understand what thinking is. Machine learning does give us some more meat on the bone, so to speak, to figure out, well, what are we really talking about? And here it's a technique that employs algorithms. We'll learn exactly what those are from data to make predictions or decisions. You know, Google used a lot of the machine learning techniques to figure out whether their computers could recognize a cat. And the performance improves when exposed to more data. And we're talking about big data here, not just a little data, but a lot of data. And then, even more sophisticated in the machine learning world, are what's called deep learning techniques or neural networks, many layers of what are engineered synapses, building algorithms that find the best way to perform tasks literally on their own or to look at other huge amounts of data. So let's dig into a little more about machine learning. The real thing to remember here is that unlike the old style AI methods that were based on expert systems where, you know, a neurosurgeon would dump their entire brain output into an artificial algorithm, we don't do that anymore. Machine learning algorithms don't have to be explicitly programmed by a human being. They can learn on their own. And the real sort of explosion in this area started probably around 2012 with a real remarkable explosion in computing power through graphical processing units. NVIDIA chips, as an example. Google strung a whole bunch of graphical processing units together to beat the world champion at Go, the Chinese game. We've seen an increase in storage capacity in the cloud, not just on our little laptops. Nobody does that anymore. Data goes up to huge cloud storage capabilities. And then the accumulation of big data, which is from the internet. Without the internet, there wouldn't be enough data. You need a lot of data for these machine learning algorithms to learn. And as we see, the newer computing methods, the neural network computing methods, the deep learning methods, this was just recognized. Geoffrey Hinton, the University of Toronto, and Dr. Hopefield, with the 2024 Nobel Prize in Physics. And this is an example. The picture that you're looking at is a actual neuron from your brain, and it's shown with about 5,600 nerve fibers that connect to it in the blue. This is actually what we're trying to do with an artificial neural network by creating a input layer, a data input layer. It goes through multiple engineered synaptic connections, looking at an algorithmic instructions as it moves through all of these layers to produce the output layer, the decision, the action, the recommendation, the prediction. This is what we're trying to do. We're trying to reproduce the brain and how the human brain works, and we're trying to engineer it through a computerized system. So we use these algorithms named after the Persian mathematician, the father of algebra, al-Khwarizmi. Apologies for my pronunciation. Essentially, they are the things that enable computer vision now in vehicles, natural language processing, talking to Siri and Alexa. They're the thing that's making it happen. And when we look at the application of algorithmic systems of the future in the workplace, they might tell us, what happened in a descriptive way. They may tell us why something happened in a diagnostic way. They may predict for us what will happen. They may support prescriptive systems, supporting our own decision making and safety. And they could take physical actions. And certainly that's what we're seeing with semi or fully autonomous actions that vehicles are taking. Um, the operational risks are significant, though, and as you know, in safety and health, we spend quite a bit of time looking at new technologies and saying, "Wait, hold up a minute. There are some issues that we want you to be aware of when you apply them to the workplace." The first thing is that you can have biases. We all know about the biases in internet data, and when you use that internet data to train a neural network, you can create a lot of problems. There can be flawed assumptions and mistakes in coding. We see that a lot. Output issues where the user disregards an algorithm's limitations or underlying assumptions, and you essentially get inappropriate application. Not a good thing. The complexity of proprietary algorithms, really advanced algorithms that can change their decision logic during their own operation, make it very difficult for designers. Sometimes the designer doesn't know how the thing is working. Certainly, manufacturers have a hard time explaining. Employers buy a device that is AI enabled. Safety professionals are trying to figure out, is it safe for the workplace? And then workers trying to gain an understanding of how the algorithm works. This complexity leads to a lack of transparency, which is a major impediment in the future as we will see more of these devices used in the workplace. They lead to a lack, as NIST, the National Institute for Standards and Technology, says, of explainability. We need explainability. When you look at all of the executive orders that are coming out of the White House and any administration, they emphasize explainability. Otherwise, we're not going to be able to tell whether it's work worthy. Concept drift. We see this when the stock market gets all excited, gets highly volatile. They have to shut it down because it's moving too fast for the algorithm as it was optimized. And then, of course, last operational risk is we don't have any standards now. We, meaning the US. However, if you're European, you do have an act called the Artificial Intelligence Act. And actually, last week, they just produced their codes of practice in draft form. So the Europeans are far ahead of us in that area. Well, what if you create a network of various algorithmic machine learning, deep learning sensors operating mechanical equipment? Imagine in the workplace. Certainly, the issue of the Boeing 737 MAX 9 aircraft, where we had a really catastrophic workplace outcome, where the angle of attack sensor sent faulty data to the maneuvering characteristics augmentation software, which caused the horizontal stabilizers in the aircraft to repeatedly pitch the airplanes down. Pilots could not get control. 2 airlines and 346 people died. So one thing I'll hear is a little commercial message for the University of Helsinki. If you all want to learn a little bit more about artificial intelligence, I really recommend you go to the Helsinki website. They have some tremendous courses. Finland said, we want everybody in the population to know about AI. And they chartered the University of Helsinki to do that for them. So I recommend that if you want to learn a lot more. So let's talk about acting, the final output, so to speak. There's a little humanoid robot there that's working in a factory. But when we talk about these steel collar robotic devices, we can go back to the 70s, 1970s, 50 years ago. Traditional robots, you can see here they were used in auto manufacturing. They're still being used in auto manufacturing. They're old style. A lot of them are in cages. You don't see any humans around. Now we're moving into more collaborative robots, robots that work together with people, service robots, ground vehicles, climbing robots, jumping robots, unmanned aerial vehicles over New Jersey, for instance. Underwater robots that were used in Fukushima to assess radiation leaks, caretaker robots that are used in social settings, and lastly, wearable industrial robotics. So we'll quickly go through some of these. Collaborative robots or cobots. They really combine the dexterity, flexibility, and problem solving skills of human workers with the strength and the endurance and the precision of mechanical robots. These manipulative arms are everywhere in advanced manufacturing. You can see the close nature of the human worker and the robotic worker. And that creates this new field of human robot collaboration, which goes to the issue of how close are these collaborations? Well, you can start out with the phase of just coexisting. They're in the same workplace, but there's different tasks. Or they're synchronized, they're in the same workplace, but they do things at a different time. Or they're cooperating, they're working at the same time towards a shared objective, but they really don't have any connection. Or you can be totally collaborative and you can work in synergy towards a common goal in the same workplace at the same time, and you need a high level of coordination. So what happens when you're in that situation and you got a human worker and a cobot? Well, you could have a collision, obviously. These things are moving. Now they have sensors that hopefully will see, touch, and feel you close to their arm so they won't hit you with it. But you could have skill mismatching where a robotic system under algorithmic control can cause a mismatch between the worker's physical or cognitive capabilities and the robot work demands. Or you could have a work intensification where the robotic pace is outstripping the human's pace. So you have a mismatch there in work intensification. And lastly, you have lots of cybersecurity issues, which we'll talk on in a minute. So service robots are everywhere, certainly in the military, forestry, police, fire, commercial deliveries. That's the new Amazon delivery that'll be coming to your house soon on your front porch. Recreational drones are being used. Your neighbor is taking a little picture of your barbecue in their backyard. And obviously, you can use them in inspection of difficult to reach areas. Lots of issues in construction where unmanned aerial vehicles are really helping doing hazardous applications, monitoring, inspecting, and maintaining buildings. Being used, drones are being used in precision farming and agriculture. Agriculture has a significant interest in drones right now for 3D mapping, crop monitoring, etc. This is a picture I took when I went to a mine in Australia. This is a very large vehicle. It's unmanned, it's autonomous. The people that are operating that are a 2-hour flight away in Perth. These open pit mines are utilizing these Korematsu vehicles today. Healthcare, these social robots are very interesting. Pictured here is Pepper, used to be sold by SoftBank. I don't think they sell it anymore. It's about $1,500. But these are new assistive robots you can see pictured here for lifting patients in nursing care. This is a robot being used in Japan, carried out an average 40 times a day, lifting a patient from a bed to the wheelchair. Obviously, this is a big issue for MSDs in healthcare worker settings. So let's talk about exoskeletons. Certainly, we know what a turtle is. We see a huge industry in medical exoskeletons, but let's talk about industrial exoskeletons, which right now are fairly passive. They're designed to amplify, augment, or reinforce the performance of a human worker's body components used in materials handling right now and in manufacturing settings to help with awkward postures, heavy workload, assembly efforts, etc. And here's a guy totally outfitted with a back assist exoskeleton, a shoulder, arm assist, a leg assist, and a tool holding. He's totally outfitted with every imaginable exoskeleton. And the promise here, and I've gone to exoskeleton manufacturing conferences where they show me a slide of an MSD rate that's on the ceiling, and then they slap all of their workers with an exoskeleton and it goes down to zero. I asked them, have you published this data? No. Can I have the data? No. So this idea that MSDs are going to disappear with exoskeletons, I'm not 100% sure that's going to be true. But studies have shown thus far that exoskeleton use does reduce muscle activity strain. It doesn't necessarily take away the MSD, doesn't do that, but it's somewhat promising, and we need a lot more research in this area. So let's look at some more advanced AI-enabled automation, and we're seeing that a lot in factories that are using advanced manufacturing techniques. And you can see that a list here of the top 12 AI use cases in manufacturing. This is really where it's happening in manufacturing. But again, we're seeing autonomous farming equipment being used in agriculture. This is a huge industry now. In $63.7 billion in 2023 in the autonomous farm equipment market. It obviously has its benefits. It reduces farm worker injuries because the farm worker is not there. The other thing I pictured here, in addition to that cartoon about the autonomous farming equipment, this is a picture I took in Holland, the Netherlands, and this is a robot that's harvesting the cherry tomatoes. And that raises the issue. A lot of people say, "Oh, this stuff is far away. In the future, it's not going to happen." But, the drivers of agricultural robotics are labor shortages, an aging workforce, a declining interest in working in agriculture, and declining U.S. immigration after everyone's rounded up. You're not going to have that many people that will be able to work. So some of these drivers of agricultural robotics are actually being recognized by the federal government. There's a federal precision ag connectivity task force to bringing broadband to a lot of rural areas so that you're able to have AI enabled agricultural. And this is some of the precision work that's going on in laboratories, tasks like fruit picking, being able to handle a strawberry without crushing it. Those people that say, this stuff is far off in the future, I think they should rethink that view because the velocity of change in this area is really outstanding. And here's an example in biology. You string together a bunch of amino acids, but you don't know how they're folded together to create a functional protein. Scientists have been working on this for decades, trying to figure this out. These two guys pictured here from Google DeepMind in London, they just won the Nobel Prize in chemistry for figuring this out through an algorithmic deep learning technique, AlphaFold. It predicts the structure of each protein from its amino acid sequence. So congratulations to those Nobel winners. As you know, there's a patient somewhere here in the operating room. It's hard to see, but we know robotic surgery is an area that's a tremendous complement for surgeons in robotic surgery. But here's a thing I want to tell you about that maybe is the other side. Maybe it's the substitute side, not the complement side. AI excels at image recognition. That's what it was built for. And what is an X-ray but an image, okay? And so this is an area that we're starting to see a lot of studies showing that AI systems for reading chest X-rays can be done, with a non-radiologist, basically, and they're equivalent to board-certified radiologist readings. So this is an area where we may be moving from complement to substitute here. So if y'all are thinking about doing a fellowship in radiology, I would rethink that. Interventional radiology, yes, but not plain film reading. May be a problem here. The other area that I wanted to concentrate on, because this really relates to worker well-being and has to do with what the management science folks and the companies call people analytics. That's their term. I prefer to use algorithmic management. This idea, we don't do the old style physical supervision of workers anymore. No, no, no. We do these advanced AI-enabled surveillance systems now, algorithmic management. And they certainly have been central to the gig economy. That's how the gig economy works, right? It's the business model. Well, now they're coming outside of gig into a workplace near you. And the effects we're looking at in terms of the literature, and this is a chart that's reproduced from my most recent article published last month in the American Journal of Industrial Medicine. It's a chart of all the hazardous issues that are associated with algorithmic management. And as you can see here, there's an accumulating evidence that this is not too good for worker well-being. And this is an area that I think we need to really concentrate more on. It's being used for significant employment decisions. You can even be fired by an AI device. And a lot of folks are having that experience. California, New York, and I give an example here, Colorado, these states are starting to think about this. California just started formal rulemaking regarding automated decision-making technologies, what they call it. New York has laws on that area, and some in Colorado that may be requiring disclosures of when you're using this kind of system, and requiring that employees and job applicants have the ability to opt out of these types of systems. So let's just briefly talk about white collar or software robots. These are all your friends. This is an avatar, Amelia. She works at a lot of banks. She speaks 20 languages at the same time. And she translates lots of languages instantaneously. She memorizes 300-page manuals in 30 seconds. Obviously, it's a labor cost reduction. She also generates a digital trail automatically, which really helps banks because they're required to do it. And there's a bunch of these friends of yours, not just Alexa and Siri, but everybody's got one of these white collar robots, and I'm sure you have several. So let's just dig into this one particular advance that we're all using these days, generative AI. This is actually not a true picture of Pope Francis, but this is a Balenciaga, $3,900, I think, is a retail Balenciaga puffer jacket, which you can get online. And this is a fake image, but it's generated by generative AI. This is a disembodied AI technology. It can generate images, text, music, audio, video, programming code. Programming code is pretty lousy, but it can generate all sorts of text. It's essentially a neural network using a huge amount of data, the entire internet, according to OpenAI. ChatGPT 4.0, OpenAI. Now there's ChatGPT 4 Pro, which you can get. I think it's $200 a year or something. But what's really amazing about this technology that suddenly came on us in November of last year, the pace of the personal computer. I mean, that took 20 years for us to really get it in terms of technology diffusion. The smartphone took about 7 years. ChatGPT took like 4 months, and it had 1 billion monthly visits. So the velocity of change, again, is extremely important. Obviously, generative AI does a lot of things. This is just a busy slide that shows you by industry sector where it's being used and what it can do and where people are dabbling in these coding, writing, reading, information sharing, conducting analysis and research. I've talked to some construction companies that are now doing a scenario design using generative AI. And generative AI, is learning more. It's getting better. It's a good student. And you can see here from the blue, that's Chat GPT 3.5. And on the x-axis are a whole bunch of tests, AP statistics, the LSAT, tests like that, the MCAT, all of that. And you can see from blue to green, Chat GPT 4, just in a short period of time, based on exam scores, is doing very well. We wait for Chat GPT 5, 6, 7, and 8, and we should be up to 100% there. By occupation, this is from Brookings. They did sort of an analysis. It's kind of interesting. You can see those areas where generative AI is probably going to make the most impact, at least, in the 40s and 50%, sales, computer, architecture, financial, etc. Not so much down in farming, fishing, construction, food at the present time. But some of those histograms may change. This is also an interesting Brookings study of generative AI exposure by salary level. And this is where I think you and I, that are probably more at the not the laborer side of the salary exposure level, we actually see more generative AI exposure at our salary level than we expected. And that's going to be interesting in terms of, is this going to be a complement to us, or is this going to be a substitute for us? Lots of limitations. Those of you that use it every day, like I do, oh my God, I just, once my session limit is reached, it just frustrates me. The context window is very small. The knowledge base, in medicine, some of these cutting edge, it gets stale really fast. Lots of biases, lots of weird hallucinations and confabulations going on. You can't validate anything, doesn't give you a reference list, kind of frustrating. This is a great example of, the tyranny of expertise is broken, shall we say, by generative AI. This is little Alex. He was on the Today Show last year. His mom underwent a 3-year search of neurosurgeons, neurologists, everything, doctors, dentists, trying to figure out what was wrong with little Alex. He had arrested growth, he was dragging his left foot, severe headaches, blah, blah, blah. So his mother plugged all his symptoms into ChatGPT 3.5, not even 4. And ChatGPT, generative AI, said, well, we thought this kid has a occult spina bifida because of a tethered cord. Your spinal cord is supposed to float in cerebral spinal fluid. It got tethered to the side of the column. The neurosurgeons detached it. He's now doing great. So that's a sort of a do-it-yourself generative AI solution. So where's all this going? I think one of the futures here that we could imagine is you use ChatGPT or other generative AI large language model as the brain, so to speak, and you marry it with some kind of humanoid or non-humanoid physical kind of robotic device with sensors, and they can operate sort of as a robot's brain here, kind of like an R2D2. These vision, language, action AI models are now under significant research by Google, OpenAI, Microsoft, and other large companies like that. The other sort of future is what are called agentic AI. This is sort of the word agent, where you can have AI that has more autonomy. It can act on its own without being expressly programmed. So, for instance, you could say, well, I want you to create a website. And an agentic AI system would then figure out autonomously how to generate its goals, like we would in terms of our phases. What do we need to do first? What do we need to do second? What do we need to do third? So it's kind of like your digital assistant on steroids. Lots of issues with agentic AI that are being researched now in terms of enhanced autonomy, improved problem solving, adaptability, personalization, scalability, construction. I would be remiss if I did not mention as a future quantum computing. This is Google's quantum computer, which is at its site at the University of California, Santa Barbara. It just announced last week a new chip that is made for its quantum computer called Willow. Basically, this is a little different kind of computing than your binary zeros and ones. This makes advantage of the quantum state, which is a probabilistic state where you could be in 0 and 1 at the same time. Don't ask me to explain it. It defies common sense, but it is real. And what Google announced last week was that its error correction rate was really significantly better, so it wasn't spewing out a bunch of erroneous stuff. I put these, 7 challenges here just to end here to tell you that all is not wonderful. Bias and misinformation, I think you all know about that because we scrape the internet. And it does create a new type of industrial hygiene called algorithmic hygiene, in which we're going to have to figure out what algorithms are doing and how they're doing it, and whether we need to audit them and whether we need to moderate them by human beings. And we all need more algorithmic literacy. This is a picture of a data center outside Leesburg, Virginia. The energy demand for generative AI and these other AI systems that are coming on is tremendous. Electricity and water is the issue. And this is a projected US data center energy consumption. When you look at it for our projected US data center share of total US power demand, we're up in the 12% range. From where we are now at around 3%. This is significant. It's causing a lot of large companies like Microsoft to say, I need more power. Where can I get it? And where you can get it is through nuclear. Some of you remember 3 Mile Island, the partial meltdown. It had 2 units. Unit 2 is the one that partially melted down, and that was shuttered. Unit 1 went offline actually just in 2019 because they couldn't make it profitable. But Microsoft said, well, I'm going to buy it because I need the electricity. So Microsoft gave them 500 million or whatever to restart Unit 1, and they're buying all the power from it. We're seeing small nuclear reactor industry development in order to power. Legal liability is a big issue. As I said, we scrape the entire internet. You start taking stuff that is copyrighted. The New York Times took exception to that recently. They started suing OpenAI and Microsoft in December of 2023. That's yet to come to trial. But Microsoft has also been very, shall we say, sensitive to this. The copyright now is being assigned to the user because they want out of this. The previous version purported to give OpenAI such rights, so they're starting to escape from that. The issue about technological job displacement is huge here, and is way back in Aristotle's day. People started worrying about that. And we have a whole bunch of history through the Luddites and everyone else. MIT's 2020 report said, well, there's no compelling evidence of job destruction overall. There's a balance between job destruction and job creation. Very nice thing to say, but tell that to the Writers Guild of Hollywood, who took great exception to the use of AI technology in replacing them, not just complementing them, but writing whole scripts. And they went on strike for quite a while. Similarly, the longshoremen also took exception to AI-based automation, and they went on strike. They settled because of the Christmas holidays and all that, but they left the automation issue for further discussion. So I think we're going to see this labor action in this area more and more. So what about workplace safety? How can it help us? Well, the benefits are huge, obviously, transferring hazardous work from the human worker to a robotic worker. But the risks are interesting, and I bolded them here just to go through them with you. Certainly, there's the risk of physical injuries from either manipulative arms like a cobot or a freewheeling robotic device in physical space. The second bullet there, these devices are using deep learning networks that have dynamic machine intelligence. They can change the way they're thinking. And if you have a static safety procedure like an old three-ring binder, that doesn't work anymore. You're going to have to think through how we're going to do safety procedures. The third bullet, algorithmic management, clearly is going to have and is having psychosocial impact on workers. The fourth bullet there, we don't have any national occupational standards in thought processes. We have NIST ethical guidelines for AI. We have a bunch of executive orders, which may be repealed soon. So the Europeans are way ahead of us in this area. I ask these questions in terms of safety. Can these devices help us recognize a near miss that we missed? Can it improve our mitigation recommendations? And can it take over? If we're going to be doing something stupid, can it stop us? Sort of like the Gord, the robot from The Day the Earth Stood Still. Now, of course, there was HAL 9000. All you remember them from the movie 2001. HAL has gotten a bad rap. HAL had really difficult instructions that were conflicting, from the base and then from the folks that were running the ship. And he didn't know who to believe and got a little haywire there. So that issue of cyber security is the last one I want to leave you with here, because if you have these robotic devices in a network, and we get hacked all the time. The healthcare is being hacked all the time. I had to get a new credit card because somebody hacked the Home Depot system or whatever. These are going to be significant safety issues in the workplace that cybersecurity is going to have to be yet another addition to the safety professionals. Lastly, there's all the Elon Musk and all that doomerism. This is an existential threat to all of us. We're going to have sort of technocratic rule. Automation is going to displace all of us. We're not going to have any income anymore. It's going to surveil us like 1984. And it's going to be very manipulative. That manipulative is starting to have traction, at least in the discussion in the United States, Europe, and recently in Australia. So this is a new era, and technologically speaking, and it will have, I think, significant effects on worker well-being as we go through time. So I'm done. Your turn now.
Should have started sooner. Thank you, Dr. Howard. Really appreciate your remarks, and we will open it up for questions. I think there's one online. John, you want to give us the first one first?
Yes, Dr. Howard, great presentation. My question is regarding maintenance repair of these high-tech systems. Is there any return on investment in incorporating these high-tech systems in everyday business, especially at small scale? The application of robotics is greatly appreciated in high-tech and high-hazard environment. For example, using them for risk assessment in Fukushima disaster. However, using them in the agri-sector demands reviews. Your kind thoughts on the issue?
Yeah, well, the issue that you're talking about is our adoption lecture. How technology is adopted and the various criteria that buyers, employers, and others use to decide, is this thing going to be useful for me? How do I adopt it? Do I have cost issues? Do I have worker acceptance issues if there are human worker collaborations that need to happen? Are there insurance issues? Are there tax issues? You know, that's a whole nother world where it's beyond some of these futures of that we're talking about today, sort of imagining these things entering the workplace. I think that's really where we're going to see a lot of exciting things develop. You mentioned the word maintenance there, and I think that's another issue that anyone who is thinking about incorporating these types of devices into their process, and you look at some advanced manufacturing companies that are doing that, they also are looking at the issue of maintenance. Any kind of mechanical device is going to require that. But unlike a purely mechanical device in the old world that we live in, is that you're going to have some computer science capabilities here, because if it is AI enabled, then you've got to understand what's happening with the algorithms that are powering that, with the particular machine learning algorithm that's being used. If you have an explainable one, and you're going to have to figure out before you even put it into the workplace, well, how do I audit this thing to make sure that I know that it's working the way it's supposed to? In the world of AI enabled devices, that's called alignment. You know, where the developer says, well, it's supposed to do A, B, and C, and then you find that in operation it's doing D and E. That's a lack of alignment, and that's a very big issue now in AI development. So your question is really excellent. It requires us to go into the next phase of understanding, and that's an important one. So thanks for that question.
We have a couple more questions here. Next question, Dr. Howard. How should occupational health practitioners be trained to recognize and address the unique risks posed by the emerging tech trends in the workplace?
Yeah, this is one that in the paper I wrote, I talked about how you would go about doing that. You know, we cram so much areas into the education of an occupational safety and health and well-being practitioner these days. How do you do this? This is very, very technical. Do we sort of give everybody a general survey knowledge? I think we probably could do that. There are some folks in our education and research centers, the one that we have at the University of Illinois Circle campus. We have a professor who has started a course in AI for occupational safety and health professionals. And I think that's something that in the areas of large universities like the University of North Carolina that has an engineering school, may have a computer science school, we need to bring those folks into our occupational safety and health educational world to at least give us a survey course, to give us some familiarity. So I think that's a challenge for ERCs that we fund. I'd like to see more sort of imaginary education happening here, where professors start thinking about, well, how can I partner with other schools? A lot of times in the past, we have done that for construction issues relative to engineering schools, and I think we can do that again for computer science. So that's where I would start on each campus, is be able to say, how can I, running an occupational safety and health program, how can I partner with people that know more about how these devices are working and can help my students understand that? Because I think it's going to essentially be an employment recruitment type skill that folks graduating from our ERC programs are going to have in order to be competitive.
Thanks, Dr. Howard. This is Laura again. I just want to pick up on the fact that we have an amazing, relatively new data science and society school here. And we have amazing collaborators both within our School of Public Health and several engineers that are in our School of Public Health and others who I think we can really collaborate with and have already made some great connections with. So really glad to hear, because I think total worker health is such an interdisciplinary field already, So I don't think any one of us can have all the expertise we need, but if we have the right teams, I think we can really put something special together, so. Yeah.
Well, that's
I know.
great to hear. Congratulations. That's wonderful. I knew you guys were ahead of the curve. And it's just wonderful. And, and the last point you made, that's the beauty of total worker health. It can absorb everything that affects the worker. And this area of human robot collaboration, I think it's one area that's especially fitted for total worker health.
Yeah. And so are there questions from the room? Yes, please, right here. And if you can introduce yourself and ask your question.
Hey, John, Chip Hughes here. How you doing?
Oh, hi, how you doing, Chip?
Hey, good. Hey, I don't know that AI reads the American Journal of Industrial Medicine. But one of the concerns that I've had and I've been thinking about is, like the big manuals, right? AI might have read or been trained on that from, 5 years ago. But I don't think AI has access to the proprietary peer-reviewed literature. And so one of the things I've been thinking about in occupational safety and health is how to be able to train AI agents in cutting-edge information around occupational safety and health. And I wonder if you have a thought about that. I've been leaking proprietary information, but don't tell anybody, okay? Because I want my chatbot to be science-based and evidence-based. Do you have any ideas about how to do that?
Right. Yeah,
ethically and
this is a
legally?
great area. And I think what I would address in your question is what companies now are doing is they're saying, I'm not sure about using all this generative AI, all this scraping stuff that goes on there. Maybe that's for the general public. But I want to take my data and I want to make a generative AI type. I want to create a large language model using a transformer neural network with my own data and my stuff that I want to put in it. So large companies are starting to do that. So there would be nothing that would impair somebody like you with the right funding, et cetera, to be able to say, well, I want to create a generative AI large language model for occupational safety and health. And then maybe you get, I'm imagining now, I'm getting kind of crazy here, but you're imagining sitting down with the major journals in this area and say, let's do something together, blah, blah, blah. So I think your idea is the same that's actually happening in large companies. So it's the same thing. It's the same model.
Okay, well, I'll have my AI chatbot work on that proposal and send it in.
Okay, sounds good.
I think the whole idea of funding this kind of work, though, is really a trick because there's a lot of proprietary opportunities, and there's, we've got to figure out what the funding mechanism is going to be for the others that are maybe not in that world. So.
Yeah, and I would just add, relative to Chip's issues, abstracts and we scrape abstracts all the time at NIOSH. So you can do that, and that gives you just enough, where somebody could say, I'm going to look at that DOI and I'm going to go further, So I think we could start out at that level.
Great,
Thank you.
Question right here.
Hi, I'm Beth Epstein from the University of Virginia. My question is about the ethical aspects of AI. I know, in medicine, the technology is way ahead, and then we do these wonderful things in medicine, and then we start asking the ethical questions. And I think it feels like we're there with AI and machine learning as well. Can you talk a little bit about that, and maybe if that's too broad a question, maybe what you know about ethical issues that are being addressed in the medical field or healthcare world?
So,
Stuff?
in the paper that I just wrote, I have a whole section on the ethical application of AI, and that chart I showed on one of the slides, which is a table from that paper, actually references a lot of the ethical side issues relative to AI. in terms of the workplace. So there's a lot going on. NIST, of course, is the sort of the federal government's repository of ethical AI, if you will. And if you go on the NIST website, there's an abundance of riches about that, which I used in the paper that I wrote. So there is a lot of work going on in that area. The Europeans have written a lot in that area. And so there's a literature that's developing, and I think it's closer, it's not simultaneous with the technology, but it's a lot closer than one would think that in normal, some of the other types of technologies that we've been that ethics have really been slow to reach. The other thing is that, you mentioned in medicine, one of the interesting things the New England Journal of Medicine just did is they created an AI journal, which is $99 a year. I signed up for it, and the articles recently, it's just started. A couple of the articles recently are on the ethical applications of AI in medicine and healthcare in general. So I found that very interesting. It's not just the sort of the technical aspects of robotic surgery and all that, and radiology and pathology and dermatology, but some of the ethics articles are really interesting. So that's called AI New England Journal of Medicine, something like that. I think you go to their website, you should be able to find it.
Thank you. Thanks.
Thanks so much. We're going to take one more question. We're a little bit over on time, but this has been terrific. You had said NIST. Can you tell us what that stands for those?
Yeah, it's the National Institute for Standards and Technology. They're in the Department of Commerce, which has got to be the weirdest federal cabinet level agency, because they have NOAA in it and they have the Census Bureau. I think all these things that they didn't know where to put, they just put in Commerce. But it actually has some functionality because you need standards to be able to, manufacturers need certain standards to be able to manufacture things and all that. So it makes some sense. But NIST is located outside of Washington in Gaithersburg, Maryland. They have a beautiful campus, and NIST is been assigned the task by the White House to develop standards in AI. And they have a lot of material on their website if you want to become a student of that.
Okay, one final question that we can make quick, either online or from the room. John?
Okay, sorry. Thank you for your presentation, Dr. Howard. My question is regarding bias and occupational AI use. Are there any worker protections from these possible biases, specifically racial biases?
Yeah, this has been a very big issue. When Amazon first used, I don't know which version of ChatGPT it used. I'm not even sure it was ChatGPT, but they had in hiring, and all the data, were non-pigmented, faces and stuff, and they had lots of problems. There were gender issues with it. Scraping the internet, you get all the good and you get all the bad, and that bias and misinformation is a serious issue when you're looking at some of those prompts that you put into generative AI. Now, they've done a lot of moderation. They've hired a whole bunch of people. That's a whole nother labor issue going on in Africa, where they've hired these people at 2 cents an hour to do some of this moderation stuff. But it's a big issue. And that's why large companies are beginning to say, okay, this is great. We like this large language model neural network thing, but we don't like some of the data that you all have. And we want to create our own industry specific generative AI program. And that's really that bias and information stuff misinformation is what's propelling those companies.
Well, this has been tremendous. We want to thank you again for all the wisdom you've just shared with us. And what we'll do is we're going to take a break here. There's probably a few more questions in the chat we may forward along.
Okay, no problem.
Again, appreciate you being
All
here
right.
with us virtually, and thank
Sure.
you so much.
Okay, thank you. Thank you.
And folks, we're going to keep our promise and have a 10-minute break. We're going to start right at 10 minutes, though. We're a little bit behind, so we don't want to get too far behind. Time to refresh your coffee. There's snacks out there, I think, so please help yourself, but we'll start right at 25 of 11.